Well, hello. So, in this channel, which I just created, it is to show people how to use deep learning themselves. Now, deep learning these days may seem to people as a magical tool which can solve a lot of real world problems. It can do object detection, it can do the image segmentation, it can do action classifications, and things like this, which we were not able to do before. But when they start to look into the code or into the mathematics of deep learning, it is so complicated and convoluted that they don't really get to know how to actually start with some minimalistic example which they can understand, and then they can build more complex codes on top of it. So by minimalistic examples, I mean that you have a very simple code which can generate the images. It is a very simple code which can generate the label which contains the information of what actually is in the image, a very simple code, a very simple network which can just do the simple task. And starting from these kind of minimalistic examples, then you can build a whole structure of more complexity in your code which can solve your particular problem. But this channel just gives you a starting point, a hands-on experience with the code itself, which is minimalistic, but on top of which you can build more complicated codes. For example, in this videos, I'm going to um, just take the codes which you can run in a terminal, and it would not have any graphical interface in terms of Jupyter notebooks. But these days you're doing Jupyter notebooks. But let's start from the very beginning. So I took a very nice example of what I found on the internet. This was a code which I forked from a GitHub repository, and this code comes with the explanation of using the YOLO algorithm to find objects in the images. So in this example, he used objects like these, and he divided this image into grid points, into grids, into 2 by into 4 by 4 grid, and then the task was to find objects like these. So I modified this code a little bit, and I have forked it on my repository. So what I'm going to show you is first how to generate a data set for training. And what I'm going to do is, like, I'm going to make images which contains text written Trump law, Biden win, Harris win, and these are the different classes to which then the image would belong to show you what I mean with this. So I generated images which contains the text only in the middle of the image, right? And now to detect this object, I have to create something called labels. So these are the kind of labels which contain the information which is in the image. So let's walk through what these labels means. So first four numbers contains the classes that I created. So I created what? Trump 1, Biden 1, Harris one, and then there is a background class which is nothing. So there are four classes. So the first four numbers are telling me that this, which class does this image belong to. That just classifies this image, which was 1001, belonging to the Trump loss class. And the Trump loss class in my case is the class number one. So it has label 1 for this class and label 0 for all other classes. Then contains these two numbers. These are the x and the y coordinates relative to the image itself. So this is 0 0.0 0.5 because the object is in the center of the image. Then I made these bounding boxes, which is like if I want to create a box around this text. These are the coordinates. Again, they are relative to the image itself. So it is whatever height and width of the box is, you have to divide it by the size of the image itself. That's why they appear as floating points. This is because any deep learning network you choose, the numbers that come out of the network are between 0 and 1 because they are somehow normalized, right? So this is what you have to do in your training level. You have to normalize these numbers itself. And then the last number is the confidence that there is an object in this box. And since there is an object in this box, I put confidence as 1. And the task of deep learning is to boil down this image to a representation which are these numbers, because then using these numbers you can actually make box predictions around where around your object where it is in the image. And this is the task of deep learning, to show it examples like these. Now this is another one, 100, and this is the training vector which corresponds to this. So again, you have now it belonging to a different class. It is in the center, so this doesn't change. And this is the bounding box for the text. And there is an object, so it has confidence 1. And the task of the deep learning is to get trained on examples like these, and then generate these kind of these kind of numbers. And using these numbers, I can in an image then know where the object is and what object it is. So this is what this program is doing. So this program is creating the data set. So what you have to do is clone this repository, and then you will get this code in your computer. And you have to set up all the Anaconda environment, and which is something which I've put up on my page, the installation instructions. But let's say you have this Python environment set up, you get the code, you want to see what is in the generate script. So in this generate script here, you can put your classes. So I put 1, 2, 3, and 4 classes. When three are the actual classes and the fourth is just the background, which is like the negative example where there is nothing in the image. So this is the example I also have in my image. For example, here there is nothing. This is none, and this also has a label which corresponds to it, right? And this is the label, that this is the background label number one, which is over here. And then these numbers don't matter anymore because the object confidence is 0. And using this script, I can generate such images. I have to choose the height and width of my cell, and I don't want to divide my image into the grid because I would just want text in the center of the image, no breaking down into grid points, into four by four grid or something. Then if there is no object, I make this as a training label. So cat 0 to 3 is the categories for which I have to assign. In this case, only cat 3 will be 1, right? Because there is no object here. And then here I define the x and the y coordinate relative to my image coordinates. And then the final one, this is the cell width and the cell height. This is the height and width of the box. And the confidence that there is object is 0. But if there is an object, I'm just going to take my x and y coordinates, which is exactly the center of the image, and I'm going to put the I'm going to make my training vector, which contains of the 4 categories depending upon if it is Trump law, Python 1, or Harris 1. The x and the y coordinates are always in the center of the image because I just want the objects to be in the center, and this is what I want to detect in this simple task. Then the height and width of the box which I create, and the confidence that there is the object is 1. So what this code is doing is it is creating two things. It is creating these images, which is storing in the images directory, and it is creating the labels which corresponds to the image, which have the same name as the image, and it is storing it in the labels directory. Because the next part of the program is going to match the image with its label to start the training. And this is the first step that you have to do to generate a data set. Now to run this code, you have to activate your Python environment, and I assume that you have done that. Then you can um, just execute this as a script, and it's not going to show you any output, which means it is actually executing and making these images and the labels directory, which you have to create first using the make directory command. So these images and the labels are the ones which you see on the screen in the blue. And once the script is done, it will fill up these directory with the images and the labels that I showed you on my GitHub page. And after you have done this, the next part is the interesting part. Now you have the vanilla YOLO program, which contains a very simple implementation of the YOLO algorithm. So in this algorithm, you ask the network to not predict one box for each object. You can ask the network to predict n number of boxes for each of the object. And I'm going to use four boxes for each object that it wants to detect. There are 4 categories, so I don't have to change this. And here I'm just specifying the height and width of the training image that I actually put in by hand. In this load image program, it is reading those images from the directory which you just created, and then it is going into the labels directory. And now this is a very important part. It is reading all these categories, right? Which are from 0 to 4, that is contained in this category vector. Then the other than the category vector, you have the high xy coordinate, height, width, and the confidence, which is coming in the x vector. But now, since in your ground truth you only had one true bounding box, but in training you are asking it to produce 4 bounding boxes or n number of bounding boxes. So in order for the prediction of the network to match your training label, you just have to duplicate the xy height, width, and confidence vector in your training to match the number of boxes that you create. That's why I create a new vector here, which is now just duplicating the xy height, width, and the confidence, which was already in the x vector. And this creates a training vector. And now the shape of the training vector matches what the prediction of your network will be, because your network is not going to give you just one box output, it is going to give you n number of box output, right? Right. So now this has to match. So in this first function, we take care of the training data matching with what our expectations from the network are. Then I generated about like 5,000 of these images, the training images, which is what I'm loading here. I'm not starting from zero, because 0 to 10 is my validation or the test set, and from 10 to 5,000 is my training set. Then you have to define the model, and in this case it's a very simple model. This model takes a fixed shape input into the network. Later you will learn that you can actually make networks which can take arbitrary shape images as inputs, so that when you input, now in this case if you want to use the program, you have to input 128 by 128 size image. But there's a way to make this network such that you can input 256 by 180 size image, and the network will still be able to give you proper predictions. That's the next step. So this is what I told you, we build complexity one step at a time, right? And in this simple model, you have to input the fixed shape of the image. This is why you have to specify the size of the object. Then you have certain convolutional layers, and this is an RGB image, so the third three corresponds to the channel, and along the channel axis you are adding these convolutional layers, right? And then in the end, the important part is what is the output of the network. The output of the networks is if I divided my image into grids, it would have to output a number for each of the grid points, but I don't have the grid. W and H for me is just one, so this doesn't matter. Then it has to have four categories, and the number of boxes is the number of box predictions I'm expecting, and I'm multiplying it by 5 because each of the box has 5 predictions attached to it: the xy, height, width, and the confidence vector. So I'm expecting it to give me 5 numbers for each box that is going to predict. And that's my model, right? So I walked you through the model. Now comes the most important part of the model, which are the losses. So it's like this: you have created the training label, your network is outputting something, but how do you train a network? And that happens when you have a loss which contains your true label and contains the network predicted label. And then it has these different loss terms which are going to define how the network is going to train itself. But I think for now, let's just skip the part which comes after this loss, and let's just start with the training of the network, right? So you know that your this program is going to take the images from the image directory, labels from the labels directory, and it is going to create a neural network which has the fixed input of height and width of the image as an input, and it's going to output 5 box predictions. So let's just try it out, right? So I'm just gonna say run this program, and you can run this program even if you don't have a GPUs. If you have a GPUs, it will run much faster. And this program was my vanilla, and I'm going to put a flag. I'm going to tell you how to put these flags also, and I'm just going to train this for 10 epochs because it was already pre-trained before, and that's it. Now this script is going to start your TensorFlow environment, which I assume you have installed from your Anaconda backend. And let's see, this is your network. It trains quite fast, the loss has to go down, and these are the losses where I actually stopped telling you about it. But the input is 128 by 128, and the channels are 3. Then along the channel axis, you are adding your convolutional filters, and at each step of this network your image gets downsampled. And then there are these dense layers, and the output is the classes and the xy and height, width, and confidence for each of the 5 boxes you ask it to predict. And in the end you get something like this. You get a prediction where it is showing you um, it takes a while to get it big, but what it is showing you is a box around where it finds the object. And the color represents the class, because I made class 1 as this, I made class second which was this one, and class third which was this one. And if there is nothing, then the box predictions don't matter. So only when you are confident that there is an object, it is going to make this box. And this is a very starting it's like this is a very quick introduction on how actually to get the object detection working. And just with two codes, two Python scripts, you are able to see this. So for the first video, I think it's enough that you know how to generate data sets and how to start training of a simple network. In the next one, I'm going to dive a bit deeper into the losses and into what are these flags that I put in. Like, right, I just said minus minus train, minus minus epoch. What is this? How do I put this in my code? This is going to be a part of the next video. And these days we don't put these flags. All of this is written in config files, which your Jupyter notebook just reads, and then it stores this information as JSON. But to do this, you have to actually go through this step of how do you actually make these arguments and parse these arguments in your program. So this is what I wanted to do: start you slow and